Greetings. I just want to do a quick and short presentation about decision making. It's always important that when these decisions are being made, that there's an element of risk integration into into the entire decision making process or framework. So basically, uh, we just want to look at using simple statistics. Okay, we are not talking about something that is complicated or looking for an application. This is your Excel. Okay, consider that this a company, can be any company, any financial institution, manufacturing entity, no insurance institution or insurance institution that is considering different projects, let's say project A to E, and the forecast shows that these are different returns, the expected returns in different period, let's say 7 years forecast for each of the projects. Now the concern of the management and board is to select the two top projects to invest in. So there are different statistical analysis that can be done. Simply just looking at the returns alone is not sufficient. For instance, if you say, okay, year one, this return $881,000, and that seems to be the highest return. Okay, so perhaps you choose project A. Okay, no, what about year two? Okay, project B seems to return the highest. Okay, we choose project B. Okay, do we choose A and B since we are looking for two projects to select? Oh, but in year two, project A return a lower amount compared to project A. Oh, but we select B and E then. But in year one, project E is actually at the top, it's actually at the bottom of the pyramid, just slightly above project C. Okay, what about the third year? Oh, the third year, look at project A doing fantastically well. Okay, but project E, project D rather, is coming up at this year three. So should we then choose A, D, or A, B, or B, E? Okay, what if we do the summation of the entire return for 7 years? Okay, so let's see what that will look like. Oh, if we are looking at the entire summation, the entire return for 7 years, we can see that project D comes up as the best choice of investment, followed by project E. So based on this, it's okay. We do D, we select project D and E, project D and E. So this is we call this our decision matrix or table. Okay, so we call that column. Okay, so based on total returns for the 7 years, the investors or the management may be inclined to select these two projects that are returning the highest return in 7 years. But what about the risk element? Okay, what about the risk? Have you considered the risk of actually meeting this return requirement? Okay, let's start with a simple measure of central tendency, which is the average. Okay, the average or the mean is the most expected value. So, given the 7 years, what is the most expected value? Okay, which is the mean. So, if you do the average, okay, do the average, okay, you can just pick up these values. Do the average for the 7 for each project. Wow, the average for the 7 for each project. Okay, we still have project D, $2.33 million, and project E. Okay, still returning on the average, still doing better than the other. So it's still D and E. So we are still selecting D and E as our project. Okay, but we've not introduced any risk. We don't understand what the risk is. Okay, so this is just telling us that our returns, okay, is centered around, okay, these particular values. Okay, on the average, you return this. So that way, if you multiply this times 7, you almost have the equivalent of this amount. That is telling you it's centered around this value. So what we could introduce some element of volatility. Okay, so how volatile are these returns in terms of dispersion of spread? So we introduce the standard deviation, which is a measure of volatility. Okay, so which is a measure of volatility, the standard deviation. You can see we are using just simple Excel. We are not doing bringing in any additional software. Okay, now what is this telling us? It's telling us that this has the highest volatility in terms of the 5 projects, okay, followed by project A. So we are looking for projects which the volatility or the risk, the level of uncertainty or the level of risk, okay, is level of risk is lower compared to the other projects. So, but this is only looking at the project standalone. Okay, it's difficult to compare based on the standard deviation. If we go by the level of dispersion or the level of volatility, we'll be selecting project B, and C, okay, which has the lowest volatility. Now, the only way all these decision matrices, okay, they are still limited. Gives you an idea, okay, but they are still limited in significant ways because these are different returns and these are different projects. Okay, now what if we have a basis to compare all the returns, okay, in a uniform manner? Okay, that's why we talk about the coefficient of variation, which measures the volatility against the expected return in terms of percentage times 100. So what we are saying is that we are going to standardize all the returns, okay, looking at the expected return as well as the risk. So that gives us the coefficient of variation. So it's just the standard deviation divided by expected return, okay, and the coefficient of variation is actually measuring the risk to reward. The lower the coefficient of risk, the lower the coefficient of variation, okay, the more optimal the risk to reward. So that means for a lower risk, you are getting an optimal return. So we are uh, looking for returns with the lowest coefficient of variation. So for that, we'll be choosing selecting project B and C. Okay, project B and C. So you see, so it's looking at all this. You see, if you're just going to dabble around, year one, year two, trying to find or make a decision based on this, you run into a lot of guesstimation. Okay, if you're just going to make your strategic decision based on the total return for the 7 year, okay, you might just be choosing a project that is subject to very high volatility, in which the expected return, okay, may fall short significantly, or there may be a significant deviation, okay, from the expected return. So that's what the standard deviation tells us about the deviation from the expected return. That is the standard deviation. Okay, so and just looking at the expected value or the average is not sufficient. Okay, and the standard deviation, which is the deviation from the expected. We want the deviation from the expected return to be small, because the smaller the deviation from the expected return, the better the the more optimized the return is. So, and the coefficient of variation helps to actually define that standardization, looking at the relative standard deviation, basically. So that is why when you do this kind of statistical analysis, don't just stop at the total amount or the expected or the standard deviation. Okay, you must do the coefficient of variation. So you can see right from beginning to this stage, we're able to come that the best project for the company to invest in, okay, in order of significance, okay, are projects B and C, given the level of risk, okay. Um, we'll talk about different other aspects at a different point in time, but this is just using Excel to do some risk quantification. See you next time. Cheers.